Objective 3 of Section 2.1, the student will be able to identify the domain and range of a function. So we've already talked about domain, how it is the set of x values. And so we've got a function here, we've looked at it already. F of x equals the square root of the difference of 3x and 2. And so f of 0, okay, what's that? Well, you put it in there and what you get is something that is not real, the square root of negative 2. You can't take the square root of a negative and have a real number. And so this function is not even defined for this particular input, 0. Well, we're interested in the set of values for which a function is defined. And so the question, for what values of x is the function defined? What we have to do for a square root function, the method, here's the method. Anytime you are asked for the domain of a square root function, set the radicand greater than or equal to 0. That's the method. Okay? Our radicand, that's the thing under the radical, the radicand, right, for f of x equal to square root 3x minus 2, there's our radicand, the thing under the radical, we set that greater than or equal to 0. Well, add 2 to both sides and divide both sides by 3, and x is greater than or equal to 2/3. And so there's your domain, the closed interval, 2/3 to infinity. All the numbers that are greater than or equal to 2/3. Here's another one. F of x equals the square root of 1/2 x minus 4. We're going to pause the video. I encourage you to pause the video and do the problem for yourself. What is the domain of this function? What is the set of allowed x values? Well, if you set the radicand greater than or equal to 0, set that radicand, the thing under the radical, which is 1/2 x minus 4, set that greater than or equal to 0 and solve for x, you should have gotten the set of real numbers greater than or equal to 8. Add 4 to both sides, 1/2 x is greater than or equal to 0. Multiply both sides by 2, x is greater than or equal to 8. So the closed interval, 8 to infinity, is the domain, the set of x values which are allowed for f of x. What about this? Well, here we have the other domain issue. Remember we said the domain is, in the first video, we said the domain is the set of x values which are allowed. And then we said, well, what isn't allowed? Well, can't have a negative under a square root, and you can't divide by 0. Any x value that results in either one of those things is not allowed. And so we're going, the method for finding the domain of a rational function, rational means fractional, more or less, roughly. If you have a rational function, well, you can't have a value of x that makes its denominator 0. What kind of value of x is that? Usually it is not 0. People always want to say, well, x can't be 0. But often, in fact, most of the time, x can be 0. But what we do is we set the denominator not equal to 0. Or we set it equal to 0, and whatever the solution is, that's what x can't be. So set the denominator not equal to 0. Okay, so you have a kind of, we'll do a kind of inequality algebra here, where we can just reason that 3x minus 5 is not equal to 0, which is to say that 3x can't be 5, which is to say that, i.e., x cannot be 5/3. And so the domain is the set of all values of x that are allowed, which is every real number except 5/3. So the domain is the set of all real numbers x such that, that's what that vertical bar means, right, in this set notation, such that, set of all real numbers x such that x is real and x is not equal to 5/3. And so that will get it done for objective 3. Find the domain and range of a function.